Okay, so let me focus on the flagship companies. The first one is Accseal. So I'm very proud to be able to show you today that we have a first SNARK ASIC, and this is what it looks like. You're more than welcome to come inspect it and have a look at it. I have another chip here. And really, I think Accseal has done a great job at just proving to the world that, yes, we can build these things. You know, it's not rocket science. It's something that's totally doable. And this chip, you know, is a fairly fancy chip, right? It's a 12 nanometer TSMC chip with die area roughly 100 square millimeters. And what it does is basically acceleration of certain workloads. So it will accelerate MSMs and NTTs, and it will also do finite field vector additions and multiplications. And it's programmable to an extent. So it's made out of these 384-bit modular multipliers, and you can basically program the prime and program your fields, but you can also program the curves in the context of MSMs. So for example, it supports BN254, it supports BS381, it supports the pasta curves. And they have a test board. So in the next slide, I'll show some of the performance numbers. These are real measured performance numbers. So this is a PCIe board. They've put 4 chips on it and 64 gigabytes of memory. This is real stuff that you should be able to buy, you know, hopefully relatively soon. And these are the performance numbers. I really want to just highlight the 2 in green there, which basically says that this chip is capable of it has the performance of a 380 Ti GPU, but obviously, yeah, it's much smaller. It costs roughly 5 times less. So your upfront cost is roughly 5 times less. And the power consumption is also 5 times less. So your all-in-all cost is going to be 5 times less. It consumes much less power. It has a much smaller footprint. And this is using, you know, compared to the 380 TPIs, is using an older node. And obviously, NVIDIA is this, you know, trillion-dollar company, and you have this startup, you know, with ex-academics, where in their very first iteration, they're able to get, you know, close to an order of magnitude on improvement on several metrics. So I'm, you know, very impressed and very optimistic by what's yet to come in this direction.